Hi, this instructional video is about finding the area of a regular polygon, and on the previous one we talked about the test that I gave to my students finding the area of a regular heptagon, the seven-sided polygon that had a side of 3 centimeters. This time towards the end I challenged the viewers to try to find the area of a 11-sided polygon with a side of 5 centimeters. If you haven't tried it yet, why don't you try it right now? Alright, so here's what I'm getting. 11-sided polygon. This time I'm not going to draw the polygon. It's getting to be a little too much here. But I'm going to take a portion of it, and let's just suppose this little isosceles triangle is one of those 11 triangles that make up the 11-sided polygon. And it says, out of that 11, see that? Little section here and little section here. Let's say, this is one of the series of the 11. That one side is 5, right there. Now I want to find the degrees for that triangle. So it's 360 divided by 11 is equal to, well, that right there is 32.72, and it repeats degrees. But I only want half of that, right there. And if I take half of that, the base of this triangle, which is a right triangle, is going to be 2.5. And so half of that 32 is going to be 16.36, and that repeats degrees. And as we talked about it last time, I have, from this point of reference, I had the opposite side. And to find the area of a triangle, which is 1/2 base times height, I need the base, which is the opposite, 2.5, or actually the 5. And the height is what I don't have. So I need the adjacent. And the only thing that's going to give me the quotient of opposite and adjacent is actually the trig identity of tangent theta. And so since we know the angle, but in fact, you know what? Let's streamline this. Instead of saying 16.36 or whatever, let's just say the tangent theta, the degrees, is in fact 360 divided by that little portion. That's 1 out of 11 triangles. Then this becomes 1 out of 22. So I need to divide that by 22 sub-angles. And that's going to be the angle that gives me 16.36. And that's going to be equal to opposite, which is 2.5 centimeters, because this is a centimeters, over adjacent. And since I do not know what that is, let's call that B. There it is. Now to speed things up, I'm going to solve for B, so I'm going to multiply to both sides by that B. And I'm going to multiply the reciprocal of tangent of 3360 divided by 22. So in fact, if I get B is equal to 2.5 centimeters divided by the tangent of 360 over 22. And whatever I get is going to give me the missing side, the height, B. So let's punch that in. Here's what I'm getting. So I go 2.5 divided by tangent, and in open parentheses, because I want the quotient to be calculated separately, 360 divided by the 22 sub-angles. And that's going to give me approximate value of 8.5514, something like that. Okay, now that's just the missing side. What I'm going to do is actually go in and find the area of the triangle, which is 1/2 base times height. So area equals 1/2 times the base is 5 centimeters times the height, which is the missing side over here, the B, which was given as this quotient, 2.5 centimeters divided by the tangent of 360 over 22. So I go, well, 1/2 of 5 is 2.5. So 2.5 times another 2.5, 2.5 times another 2.5. I can't find the square key, so I just go, that's 6.25. 6.25 centimeters squared over the angle of tangent 360 over 22. And that gives me, divide that by tangent. I did this already, but I'm going to do it again. 360 divided by 22. That's going to be 21.2855. 21.2855. However, that's the area of one triangle. So I have to multiply that by a total of 11 triangles. So I get the total area, which is about 234.14 centimeters squared. So that's my answer. And let's see if that is one of the choices. Do I see anything 234.14? Right there. Ta-da! So you could play with this, try your own variation by changing the polygons and changing the sides and see if it works out for you. Okay? All right. Go get some.